For 3 years, Rijutha has been a PhD student at the Department of Physics and Astronomy at Aarhus University. Today, Rijutha is going to collect data for one of the last experiments in her PhD before she submits her thesis. The experiment that Rijutha is going to perform today is called the temperature-programmed desorption experiment. Rijutha starts with a clean carbon surface called graphite. This is the same type of material as is found in dust grains in the interstellar medium. On top of this sample, Rijutha will build up a film of molecules called polycyclic aromatic hydrocarbons. The objective of the experiment is to heat this film of molecules and measure the temperature at which they start to desorb from the surface of the carbon material and move into the gas phase. The desorption of the molecules into the gas phase will be detected with a special instrument called a mass spectrometer. This video will show and explain the equipment that Rijutha is going to use to perform the experiment. She begins by cleaning the sample by heating it to a very high temperature. The sample begins to glow red at the center of your screen when it reaches 900 degrees Celsius. Rijutha then has to move the sample into position inside the ultra-high vacuum chamber using the manipulation tools available outside the chamber. As Rijutha turns the handle, the sample slowly moves into position. First, Rijutha deposits the film of molecules by bringing the doser as close as possible to the sample surface. The molecules move from the doser onto the graphite surface. Because the tools inside the chamber operate in vacuum, it can sometimes be quite difficult to move things from outside the chamber. Once the film of molecules is prepared, Rijutha again moves the sample, this time to put it right in front of the mass spectrometer. Eventually, everything is lined up and Rijutha can begin the process of heating the sample to force the molecules from the surface back into the gas phase. As the sample gets hotter and hotter, eventually the molecules can no longer stay on the surface of the graphite and desorb into the gas phase. The desorption of molecules from the surface into the gas phase is detected by a special piece of equipment called a mass spectrometer. The mass spectrometer can not only detect when molecules arrive into the gas phase, but can also sort those molecules according to their molecular weight, to charge ratio. All of the species in the gas phase enter the detector at the same time. The detector uses an electric field to separate the species with a high mass to charge ratio from the species with a low mass to charge ratio. In this example, only the smaller molecules, those with a small mass to charge ratio, make it through to the detector. Rijutha has started the experiment, the sample is heating, and now she's waiting at the computer to see the signal coming from the mass spectrometer. The sample heats at a constant rate of 1 degree Celsius per second, so it takes about 10 to 15 minutes to run each experiment. Some of the data has arrived, and Rijutha and her PhD student colleague Frederick have a look to make sure that everything is working in the experiment. As the sample heats, the signal that reaches the detector and mass spectrometer increases slowly with temperature, until eventually there are no more molecules left on the surface and the signal starts to decrease again. This gives a characteristic peak shape to each temperature-programmed desorption dataset. The data that Rijutha is particularly interested in is the temperature at the top of this peak. The experiment is finished and it's time to turn off the equipment. Rijutha sits down at the computer to check that the data look correct. This is exactly the peak shape that Rijutha was hoping to see. As the temperature increases, the peak gets higher and higher until a peak temperature is reached and most of the molecules have desorbed from the film. Rijutha can now use the software to find that peak temperature and her experiment is complete.